Okay, so this is the first video in the 1-4 describing motion mathematically discussion, and this is where we're going to put everything all together. We're going to create some formulas here that will help us learn how to solve problems. And please don't freak out about all of this. There are going to be 5 formulas that we're going to learn, but you will always have them on your tests. You'll never have to memorize them or anything like that. You'll just have to learn how to use them, and we will very, very thoroughly describe how to use them and how to figure out which ones to use. There's a strategy that's going to just really make this simple, and you will literally be able to solve any motion problem given to you in one dimension. That describes motion in one dimension. Okay, so let's go ahead and look at this discussion. First of all, the learning target. I will be able to describe and use a strategy involving the creation of motion diagrams and a standard set of motion equations to solve any basic motion problem in one dimension. And the reason that we want to create this strategy is because and you've probably noticed this in word problems before, there's a lot of information in the problem that is implied. It's implied, it's never stated outright or explicitly. And it makes it likely that if you do not use a standardized strategy to solving these problems, information important in solving the problems will be missed. Okay, so that's why we're going to do this. So how you're going to do this, you will correctly employ a standardized strategy in solving basic motion problems 80% of the time. So this section creates mathematical rules that describe the relationship between position, change in position, change in velocity, and time interval during a period of constant acceleration. So that's our only two types of motion. Either I'm accelerating constantly or I'm not accelerating. So constant velocity and constant acceleration, these are two different things, right? Don't get those mixed up. But the only scenario where we'll look at acceleration is where the acceleration is constant. And this allows us to make predictions about unknown quantities associated with specific motions. Now, the conventions that we're going to use in this, I will usually, not always, but usually say that position is going to be symbolized by x0 for the initial position and x for the final position. Velocity is usually going to be x0 for the initial velocity and v0 for the initial velocity and v for the final velocity. And then for time, since time usually the initial time is 0, we're just going to ignore it and just call it time, not time 0 or time. So if I have a change in position is also called the displacement, right? So if I have a change in position from x0 to x, the change in position is going to be x minus x0. It's always the final number minus the initial number, right? So for velocity, the change in velocity is going to be final velocity minus initial velocity. Again, for time, we don't need a delta t because t0 is usually 0. And then the two formulas that we've created so far, velocity is the change of position divided by time. How fast did I change that position? How many meters per second did I change that position by? And then acceleration is how fast does the velocity change? How fast do I go from 0 meters per second to 10 meters per second? Do I do it by 1 meter per second increments or 2 meter per second increments or 5 meter per second increments? Okay, so these are my formulas so far. Okay, so in order to be able to make it so that you could go to any one of our formulas and review how we got this formula. And by the way, I don't need you to know how we got each of these formulas, okay? I'm going to go through and show you how we got each of these formulas because it's not fair to you to just say, here, memorize these formulas, and then not tell you where they came from. Okay, if you know where these formulas came from, even if you can't recreate the derivation or the how we got the formula, even if you can't recreate that, having seen me go through this will still be helpful to you in understanding the formula. Okay, now because I want you to be able to just go back to any one of these individually if you want to see if you for better understanding of it, I've split these up into 5 little video clips for each one of these. So we'll watch each one in the context of this video. But you can go back and watch each video individually if you want to. And then you could also look and I will have put on here also the solution or the derivation of the formulas on here, so that if you want to, well, you'll need to write them down anyway as you go through the individual videos and the worksheet. Okay, so make sure you've got your worksheet with you because you're going to be writing all of this stuff down. So for each one of these, I want you to write down the work that we go through to get each formula. Okay, so for the next little while here, and we'll have to go through a couple of different videos, but I'm going to just open this video up, so it'll be kind of a video within a video, and you can listen to this as we go through this, and then we'll go through each different formula. Okay, so as we're talking about creating mathematical laws or rules to describe the relationship between position, velocity, and acceleration in time, we need to start to get used to how we can manipulate these formulas to meet our needs. And we're going to end up with 5 different formulas, and don't worry, you'll never have to memorize them, although I'm sure some of you will. You'll always get these on tests. My only concern is that you know how to use these formulas and how to be able to decide on which formula that you need to use. But anyway, we designed several formulas for certain circumstances. My favorite one is where we don't have time. We're not given time, and we have to use the final velocity with constant acceleration formula without time to solve problems. So we create these formulas with different goals in mind. Do we want the final position or the displacement if in the circumstance where we don't have a final velocity, or where we have both the initial and final velocity but no acceleration? So we created these different circumstances, and we're going to start with, we're going to use the average velocity formula to create a formula to determine displacement under the conditions of constant velocity. Okay, so that's our first goal here. Use the average velocity formula to create a formula to determine displacement or final position under the conditions of constant velocity. So we know what our average velocity formula is. It's V, except we need a bigger line there. V equals delta x over time. And we know that we can expand delta x because it's the change in time, or the change in position, right? So it's the final position minus the initial position over time. And this is a formula we want to use, and we want to create a formula that solves for how far did I go. Okay, my final position minus my initial position. How far did I go given a certain velocity and a certain time? So all we're going to need to do here first, if I want to get x by itself, we're going to have to move the denominator over here. So we're going to multiply both sides of the equation by time, and that's going to end up giving us time times velocity equals x minus x0. Okay, so I just multiply both sides of the equation times time, and here I can do this. Time cancels out over here and leaves me with that. Okay, the next thing I need to do if I want to get x by itself is I need to add x0 to both sides of the equation. So I'm going to add x0 and add x0. Okay, and that leaves us with x equals x0 plus velocity times time. Okay, that's going to be our first equation, and this is what I want you to put on your worksheet. This derivation. This is called a derivation. We derived the formula. We started with the velocity formula, and we ended up with this formula. And we want to name this so that it gives us a clue as to what it's used for. Okay, so we're going to call this the final position, because that's what we get, right? That's what we end up with, the final position. Final position. And this is under the circumstances of constant velocity. This v here cannot be an accelerated velocity. It has to be a constant velocity, or this formula doesn't work. So we're going to say final position with constant velocity. And that's what you need to put down for the name this part of it on your worksheet. Final position with constant velocity. Okay? So this is the first equation that we've gotten. So we're on our way. We're gonna kill it here. Okay? So go ahead and go to the next one. Okay, so I'm not sure where my screen is here. Let me see if I can get that back. So I guess I've lost my little viewport where I'm showing up here. Hold on, let me go see if I can get it. So I guess we'll just finish this out without well, and in fact, this video needs to end because it's getting close to the ending time. So we'll go ahead and do the rest of these equations in the next couple of videos. But let's end this one and go to the next one.